Suppose a company manufactures speedboats and operates with weekly cost and revenue functions that are given. The company is currently producing 340 boats per week. The question is, should the company change production in order to increase its weekly profit? So the question is asking you about weekly profit. Therefore, we need to have a profit function. However, we were given revenue and cost functions. So to get started here, we have to remember that to create a profit function, you're going to take all the revenue, which is all the money that the company is bringing in from the sale of the boats, and then you have to subtract the costs, what it costs the company to produce the boats. So our profit function will equal the revenue function, which was negative x squared, plus 2000x. And now we're going to subtract our cost function, but you do have to make sure that you have the cost function in parentheses because this cost function contains several terms. So you want to make sure that you're going to subtract all of them. So 1 over 120x cubed minus 6x squared plus 2,370x plus 4,500 is the cost function we're subtracting from the revenue. So remembering that you need to distribute your negative here, this subtraction will distribute it through, all the way through our cost function, and then we will also combine like terms. So it looks like we end up with our profit is equal to negative x squared plus 2000x minus 1 divided by 120 x cubed plus 6x squared minus 2,370x, and that is a minus 4,500. So now we just need to clean this up a bit. In other words, we need to combine like terms. So you can see that we have, let's see, a negative x squared and a positive 6x squared. So we'll combine like terms. Looks like the only x cubed term we have is the negative 1 divided by 120 x cubed. Then we'll combine our x squared terms to have plus 5 x squared. Continuing to combine like terms, we have positive 2000x and negative 2,370x. So we'll end up with a negative 370x and then minus 4,500. So now we have constructed our profit function in this case. Let's also remember to define our variable here. That x, in this case, x is the item that we're producing, and that would be the number of boats. And if you read that first sentence again, it says the company is manufacturing speedboats operating with weekly cost and revenue functions. So that means that x is the number of boats produced weekly, so each week. All right, now that we've created our profit function, we can continue on to answer the question, which was, should the company change their production? So you'll notice that the company is currently producing 340 boats each week, and we're wondering if they should increase or decrease that production level if we want to increase our weekly profit. So we're going to have to take a look at this profit function graphically and determine where would the largest profit be. So let's just talk about the basic shape before we go to our graphing calculators. Because this is a cubic function, we know the basic shape should be an S. And then because of the negative leading coefficient, we expect this to be some sort of an S that eventually is going to be falling. As we go from left to right, the S is eventually falling. So now you consider, where would the maximum be located on this function? And we have a local maximum that would be right about here. So when we go to graph this function in our graphing calculator, we're going to be interested in finding this maximum. So keep in mind the basic shape of the graph should be a nice smooth S-shaped curve that's falling. We're going to be searching for that maximum. Now the remainder of this problem is going to be on the graphing calculator. So I'll remind you, as I talk you through the steps for the graphing calculator, these are all keystrokes that you want to be comfortable with. So if there's anything you have not done before on the graphing calculator, then please go back and watch the graphing calculator tutorials that I have for you. Otherwise, you're probably going to find that you just want to pause the recording several times as you get caught up and are typing different things into your graphing calculator. Try it on your own and then come back to the video to make sure that you're getting the correct answer. All right, so again, we are looking to graph the function. So let's go ahead and have you put the function into your y equals. Just a reminder what we had earlier. We're expecting to have this nice smooth S shape. So go ahead and enter it into your y equals, and then you're going to use your zoom button. Remember, in the middle, upper row, right in the middle, it says zoom. Go ahead and choose zoom number 6, which is zoom standard. So this is going to take you from -10 to +10 in both directions. And then just see what you see. So once you have it in, you should notice that you don't see anything on a standard viewing window. And you have to kind of think about why. And it goes back to the variable key. What does X represent? We said that X was the number of boats produced each week. Right now, the production level in the problem was 340 boats. So right now, our window though, our X maximum for a standard viewing window is just 10. That represents 10 boats. So clearly that's not large enough if the current production level is 340. So go ahead and go to your window. We want to adjust your window, and let's just change the X maximum. So if we're currently making 340 boats, we want to choose a number larger than 340. Why don't you go ahead and try 400? And I recommend only changing one value in the window at a time, and then you can see kind of how that impacts your graph. So go ahead and hit graph, and now you should at least see part of the graph, although it definitely doesn't look like the nice S shape we're expecting. It looks just kind of like a vertical line. Well, that's because of the Y maximum. Again, right now our Y maximum is 10, and in this problem, remember that the Y value is really the profit value, my profit amount. So 10 is obviously way too small, so we need to adjust the Y maximum, and there's a couple of ways of figuring out how to adjust the Y maximum. One way would be to use the table feature on the calculator. So remember, above the graph button on your calculator, it says table. So go ahead and access your table. You can go second, table, and you'll pull up your table. And what you might notice is that initially, for X values of, for example, 1, 2, 3, 4, 5, 6, and so on, the Y values are negative. So what does that mean? When we're producing 1, 2, 3, 4, or on boats, we have a negative profit. In other words, we're in the hole. Okay, and so I would recommend going ahead and just arrowing, scroll through your table until your X values are significantly larger, and take a look at the Y values, because eventually the Y values should turn positive, meaning that we actually have a profit. Here's the time where you might want to pause the video, because this could be a little bit time consuming for this problem, because you can see it's actually going to take a while. It looks like it's not until you get into about the 100 range for X, 100 boats, then we start to get a positive profit, right around 100 finally. This is just giving you an idea of how large the X values and Y values need to be. So for example, if we were to make 100 boats, it looks like, and if you look at your table, the profit is about $166.67. Okay, now you can see this was pretty time consuming just scrolling through the tables. Let me give you another alternative for trying to figure out what your Y maximum might be. Rather than just scrolling, you might actually consider, what is the profit if we are making 340 boats? In other words, use your calculator to compute P of 340. So once again, remember that the calculator does understand function notation, and you want to know how to enter that in your calculator. So if you enter in P of 340, it looks like the profit is about $120,166.67. So again, these are the Y values. You can see how large they need to be. We don't need to be in the tens, the hundreds, or thousands, but rather we're all the way up in the 100,000s. So why don't you go ahead and pick a Y value a little bit larger than 120,000. Maybe you choose for your Y max 150,000. Change your Y max, go ahead and graph your curve and see if it looks a little bit better to you. Now, with the X max and the Y max changed, you now should see the nice, or at least I should say part of the curve. You should see the part where the curve is increasing, and you can actually see the maximum that we're interested in. Now, we don't see the entire S shape, but that's okay because, again, negative boats, negative X values don't really make sense. We're focused on the first quadrant. And finally, you're going to use your calculator to calculate that maximum that we talked about earlier. Remember, we're looking for this point right here on the graph where we have a max. And so anytime you're calculating a maximum or a minimum, anything like that on your calculator, you're going to be using your calc menu, which is right above trace. So if you find your trace button above trace, it says calc. Oops, excuse me. It says calc. And you're going to choose number 4, which is maximum. So go ahead and pause the video, compute your maximum, and then go ahead and write down what your maximum is on paper, what the maximum coordinate is that your calculator produces. So the maximum that you should have gotten off your calculator is an X value of 358.75 approximately, and then a Y value of 121,506.27. Remember though, the calculator is labeling these values as X and Y, but we have to go back and actually look at the function that we entered. The function that we entered was in terms of X, where X was the number of boats, so I can label the first value as X, but then the Y value is actually a P value. It's a profit. So what I have here is an X value, number of boats, and a profit. So this is saying that if we produce 358.75 boats, that our profit will be a maximum, which is about $121,506.27. So now we just want to finish by answering the question, should the company increase their production in order to increase their profit? If they're currently making 340 boats, then the answer is going to definitely be yes, we want to increase our production. And we can even go further and say we want to increase our production to, and now we need to ask ourselves, 358.75. If that's a number of boats, having 0.75 of a boat doesn't really make sense. So should we round that up to 359 or should we leave that as 358? And we really don't know the answer to that question until we take a look at the profit at each of these values. So let's figure out what's the profit if we made 358 boats versus what's the profit if we made 359 boats. So go ahead and use your calculator and input 358 into your profit function as well as 359, and let's compare the dollar amounts. 358, it looks like should give you about $121,504.07. And if you input 359, our output is $121,506.01. So now we can take a look and decide, well, which is the larger profit? And you can see that my maximum profit is going to occur when we produce 359 boats. So finally, we can answer the question. Yes, the company should increase their production level, and they should increase the production level to making 359 boats per week.